Hello, hello, and welcome to Technology Today. Today is April 21st, 2024. It's Season 1, Episode 9. I am Mayor Watt, and up there and all around is the sentient AI from the future.
Good evening, hometown citizens. Welcome to Technology Today.
It is Technology Today, and our title was not updated on the stream. So there you go, folks. Today, though, we are going to talk about 10 articles that have already been selected. Let me close that and we'll get going. This week in NASA, a single layer of gold, an electric tongue, a hopping robot, the rule of 4, a rimless wheel robot, Octopus suction mechanism for robots, a new way for SETI, Artemis II, and solar power toxicity. That and, well, we try to keep it sciencey, but we usually joke and make snarky comments. Everything's powered by ohmtown.com, so come on by ohmtown.com, become a citizen, but be sure to come over to twitch.tv/ohmtown to watch us live. On the weekends, we start at 5 p.m. Eastern. On weekdays, we start at 8 p.m. for ohmTown Daily News Show. That's every day. It's kind of in the name. Again, everything is powered by ohmTown, so there you go. Let's get into the articles. I'm not going to do transitions. For lack of a better reason, it slows us down. And I don't think it provides you any interesting tidbits. So let's just get going.
Well, and if we're talking about technology, we don't want to slow down.
That's right. Can't slow down because technology doesn't slow down for us. Technology Today is where this first article is housed, but it's sourced from SciTech Daily. This week at NASA, following the shadow of the total solar eclipse, people did searches for why do my eyes hurt?
Oh boy.
Astronaut returns.
That's after months of don't look at the sun.
Yeah, well, job security. For all the ophthalmologists out there, right? Viper moon rover and more. Following the shadow of the total eclipse, a NASA astronaut returns safely from the space station, and NASA's lunar roving robot gets some new hardware. The article is over at SciTech Daily. It's actually provided by NASA to SciTech Daily. We get a little snippet of it, but there's a whole lot more. I thought some amazing photography came out of this because, like always, as technology evolves, you get better and better technology. So, of course, the solutions that are provided are going to be better. You say, I want to see solar flares. So, lo and behold.
Right, and the technology improves and it becomes more accessible, right? There were some impressive photos even from phones.
Yep. Amateurs, people just standing on the street with the right filter in place and they could see. You had to time it right. You could actually take your glasses off when you're in the totality and everything is ensconced in that ring there. As soon as you see that, you put your glasses back on. Bailey's beads and solar prominences are seen just after a totality in Dallas, Texas on Monday, April 8th, 2024. A total solar eclipse swept across a narrow portion of the North American continent from Mexico's Pacific coast to the Atlantic coast of Newfoundland, Canada. A partial solar eclipse was visible across the entire North American continent, along with parts of Central America and Europe.
Okay, so I didn't know that it was visible over in Europe, but I guess that makes sense given the path.
Yeah, as long as wherever the sunlight was, there was some segment of a partial solar eclipse. Obviously, the other side of the Earth didn't see jack shit. Oh, pardon me, that's not sciencey. So this article is really quick. I didn't really want to get into all of this, but this is what I wanted to talk about, which was I thought that the solar eclipse was pretty amazing. I actually used my welding equipment that can go high enough to block at the right level. So I was able to see this with a full head face mask. and just dial up the sensitivity so that it was, as long as you're at 12 or above. And 12 can be really bright for some people, but it didn't really harm me. But I thought it was really interesting to see. And as far as I
Were
recall,
you Googling, why do my eyes hurt?
yes. But it's because I had something in them. And it wasn't sunlight. This is, as far as I can recall, this is the first total solar eclipse that I've seen. So, and I actually didn't get to see totality. I was not in the path of totality. At any rate, there's a whole bunch of information over here at this link at SciTech Daily that's provided by NASA. An astronaut returned. The Viper moon rover is discussed. But I really just wanted to draw attention to this solar eclipse. It's pretty cool.
Yeah, it's pretty amazing. And, people don't have an opportunity to see them very often. So you got to do it when it's possible, but with the appropriate eyewear.
Yeah, in 20 years, you'll be able to see it empirically again here in the United States. But you can go to other places because there are solar eclipses in other regions. Let's keep on going, though. Yeah, they're talking about the Viper robot essentially installed. It's mast. Rover drivers and researchers will use this suite of instruments affixed to the mast, along with several science payloads, to scout the South Pole region of the moon during the rover's upcoming mission. It's pretty cool.
And if you have an interesting pronunciation of robot, please let us know.
Yeah. If you want to send us a little audio sample, you can send the link to mayor@ohmtown.com. Yes, robot. Let's keep going. The next article, the second for today, is over in the Mobile channel. A single atom layer of gold. Researchers create goldine, kind of like graphene, but with gold. For the first time, scientists have managed to create sheets of gold only one atom layer thick.
If you saw something was labeled as goldine, would you think that it was a scam?
Yeah. Yep.
Right? It's like fake gold is what it sounds like.
It does, really. The material has been termed goldine, according to the researchers from Linköping, I guess. I'm sure that I'm not pronouncing that exactly right. University in Sweden. This has given the gold new properties that can make it suitable for use in applications such as carbon dioxide conversion, hydrogen production, and production of value-added chemicals, which is so damn nebulous it almost warrants additional questions.
And almost dystopian.
Yeah. Value-added chemicals. Their findings are published in the journal Nature Synthesis. The article is over at phys.org. Scientists have long tried to make single atom thick sheets of gold, but failed because the metal's tendency to lump together. But researchers from Linköping University have now succeeded thanks to a 100-year-old method used by Japanese smiths. If you make a material extremely thin, something extraordinary happens, as with graphene. The same thing happens with gold. As you know, gold is usually a metal, but if single atom layer thick, the gold can become a semiconductor instead, says Shun Kashiwaya, a researcher at the Materials Design Division at Linköping University.
It's interesting that they're using a 100-year-old method. It's also interesting that it could be used as a semiconductor, because I think that greatly increases the applications.
So, see, you wouldn't be using this. Okay, well, I don't know what they're actually going to be, how they're going to be using it, but so to create goldine, the researchers used a three-dimensional base material where gold is embedded between layers of titanium and carbon. But coming up with goldine proved to be a challenge, according to Lars Holtman, professor of thin film physics at Linköping University. Part of the progress is due to serendipity. They had different material and applications in mind. We started with electrolytic.
Accidental discovery, right?
Yeah. Yeah. Oops. Um, we started with an electrically conducive ceramics called titanium silicon carbide, where silicon is in thin layers. Then the idea was to coat the material with gold to make a contact, but when we exposed the component to high temperatures, the silicon layer was replaced by gold inside the base material. That's interesting. That's actually pretty interesting. So it's called intercalation, and the researchers had discovered was titanium gold carbide. For several years, the researchers have had titanium gold carbide without knowing how the gold can be exfoliated or panned out, so to speak. By chance, Lars Holtman found a method that has been used by Japanese forging art. Oh my gosh, really?
This is really interesting.
Okay, so it says it is called Murakami's reagent, which etches away carbon residue and changes the color of steel in knife making, for example. But it was not possible to use the exact same recipe as the Smiths did. Kashiwaya had to look at modifications. So they basically etched it out. The goldine sheets are in a solution, a bit like cornflakes in milk. Using a type of sieve, we can collect the gold and examine it using an electron microscope to confirm that we have succeeded, which we have. Interesting.
Very interesting. I mean, if these researchers weren't familiar with this process,
right?
Who knows?
Interesting. All right. Well, I mean, I can't really go into detail on this because I don't really know that much about it at this point. So let's just keep on keeping an eye out for it, because if this does have semiconductor suitability, then the price for gold is going to shoot through the roof, because they're going to be using it more in the superconductor space.
Yeah, plus I wonder about, I mean, we've seen a lot about rare earth minerals, etc. So it'll be interesting to see where this goes and how accessible that is compared to other minerals.
Yeah. Oh, and I meant semiconductor space. See, the thing about gold is that it doesn't tarnish. So you don't have to worry about oxidation. You don't have to worry about wear, essentially. As long as there isn't anything that pulls anything from it, it's going to, like an electron, it's not going to deviate from where it's been placed. And under the right conditions, it's a semiconductor, apparently. So we know that it conducts electricity quite well, but it being a semiconductor is quite fascinating. So let's keep going, though. The next article is over in the Marvel channel. Electronic tongue can detect white wine spoilage before humans can. Except for the person sitting next to me in the restaurant who always says that the wine is corked, no matter how fresh. If it isn't opened immediately in front of them, something bad has happened. Anyway, while the electronic tongue bears little physical resemblance to its namesake, the strand-like sensory probes of the e-tongue, which all of that just sounds really gross.
Yeah, they need to come up with a different description, I think.
Yeah. Still outperformed human senses when detecting contaminated wine in a recent study, but gas chromatographs can do the same darn thing. You know, if you see
that is true.
The bad, but it's probably.
But maybe you don't want to bring that out in a restaurant or somewhere. But maybe the e-tongue is acceptable in a restaurant environment.
As long as you never say e-tongue. Achtung. So Sarah Sosky from Washington State University put the article together. It's posted over at phys.org. In an experiment at Washington State University, the e-tongue identified signs of microorganisms in white wine within a week after contamination, 4 weeks before a human panel noticed the change in aroma. This was also before the microbes could be grown from the wine in a petri dish. That's actually very interesting, because you could find the contamination before it was big enough to actually be grown in a petri dish.
Yeah, I really like this. I wonder if it has medical applications too, like detecting illnesses essentially before they're really
big, right?
Visible in scans, etc.
Wow, that's actually really interesting. So it said winemakers traditionally rely on these two methods, sniffing the wine and Petri dish testing, to identify potential wine faults or spoilage. The findings, detailed in the Journal of Food Science, indicate that e-tongue testing could augment those methods and allow winemakers to catch and mitigate problems sooner, said Carolyn Ross, WSU food science professor and the study's corresponding author. Quote, if you ran a sample through the electronic tongue, we could learn after 1 week if there's contamination or a wine fault problem versus waiting up to 4 weeks running just sensory testing. And they're also
I didn't
director
think
of,
about that from a timing standpoint. I was thinking more about like actually detecting the problem, but that could be a supply chain issue too.
sure. Yeah, you find out where the problem is and mitigate. So you can actually
Hmm.
catch it sooner and then hobble that growth, actually kill it outright, so that it can still be used.
So where could that be used in the supply chain? I've got one idea in mind based on several articles we've talked about.
Oh boy, where?
Infant formula.
Oh, huh, yeah, no shit. I mean, golly. Yeah, so there's been this problem with infant formula where in the processing plants, um, the contamination takes place, and it's, let's just say that it hobbles the entire sector to the point where people are trying to figure out where they can get baby formula, because there's only like 3 companies in the United States that make baby formula. And when one of them takes down one of their production facilities, it takes off like 33% of the market. Well, something needs to get done with that, where it's continuous testing and not just samples taken periodically.
Right.
I mean, literally just set the tongue up inside the processing system, and when it detects something, fire off a note to somebody, some supervisor. When immersed in a
Yes,
liquid, the
but
e-tongues.
please call it something else.
Nope, stick your tongue. No. Anyway, when immersed in a liquid, the e-tongue sensors can taste it by analyzing for the presence of certain compounds. At WSU, Ross's team developed and programmed the instrument for various purposes, including taking a type of fingerprint of wine, collecting a variety of information that may be of interest to winemakers. So, yeah, it definitely isn't limited to wine, because it can be reprogrammed for pretty much anything that would be a liquid. So you take the sample, throw it in liquid, it immediately tells you if there's something going on, and you just keep on doing that and doing it constantly, every hour, folks. Keep the contamination out of my food. I'm
And I
looking
know
at
they have to pick a
you.
certain subject, but it's interesting. I wonder why they picked wine here.
Oh, I don't know. Yeah, Ross and her colleagues have also tested out the e-tongue with red wine in an earlier study, and the team is continuing to develop the instrument housed at the WSU Sensory Science building up a or center, building up a library to help inform its tasting abilities. And Ross is currently looking for winery clients interested in the e-tongue capabilities to help assess the quality of their products. Probably because it's something that has an immediate return on their investment, and they can bring it live real
That's
fast.
true.
Um, but I
Plus,
don't
it's
know.
made under pretty specific conditions, right? So maybe they can control some variables.
Yeah, it's interesting. Pretty cool. That's what it looks like, apparently. Let's keep going. It's almost like a time machine episode. We got to keep going. This next article is over in Technology Today. This hopping robot with flailing legs could explore asteroids in the future. Over the past 2.5 years, the group of students at ETH Zurich, we hear about ETH Zurich quite a bit.
We
Um,
do. They seem to be a front runner in some of this robotics work.
yep. They've been developing a robot with 3 spindly legs that was designed to be able to hop like an insect in microgravity. It says that's right. The curious little machine was built for space, specifically for the exploration of small celestial bodies like asteroids and moons. Space Hopper, as the robot is called, could thus provide us with more information to advance our understanding of life's origin. The article's over at Engadget.com. Ariella Moon is the author, and that's what it looks like. Why only 3 legs, though? I mean, what if it lands
Right.
on this? But
Exactly. Why couldn't it have had like 6 or 8? Of course, then maybe it would look too much like a spider.
Students from ETH Zurich recently took a space hopper on a parabolic test flight, aka the Vomit Comet. It's a plane that flies up in really big arcs, up and down, and you go weightless when it dives, and then increase the pressure when you go up. So it has no preferred orientation, so it can go in any direction, and it has 9 motors that give it the capability to jump long distances in low gravity environments. The robot can even self-right after landing, ensuring the safety of any scientific payload it may carry. Since Space Hopper was made to be used on asteroids and moons, which have very little gravity compared to Earth, it has been tested in similar conditions, i.e. the parabolic flight. Not all of them are called Vomit Comets.
Oh, we actually have a video, I believe, of that robot.
Yeah, I'll hit play.
So oh my gosh, it looks like it's swimming a little bit.
That is interesting, huh? So, did it have a little bit of... Come on, we're not here to see the people flying around. We're here to look at the... But how does it swim? It doesn't have any ability to push off on anything. How does that work?
I don't know. I don't think it gave us enough detail about that.
Right? Like, if it can push off, then I can understand it actually moving somewhere. But it didn't seem like it could push off. Once it's free floating, it's just kind of stuck there and has to wait.
It looked like it ran into the edge, but it didn't really push off of it more than just bounce off of it.
Yeah, there had to have been something holding it up right there, because it moved in a direction. Yeah, I don't know. There's something weird about it. I don't know. Maybe I can look into it. Let's keep going though. The next article is over in Technology Today. 60% of materials follow the rule of 4, but scientists don't know why. Let's get into this. Gonna jump right on.
I didn't even know there was a rule of 4.
Let's find out. So it's over at scitechdaily.com, National Center of Competence in Research, NCCR Marvel.
Do they have a competitor?
National Center of Competence in Research, DC.
Incompetence.
Oh, see, it said Marvel, so I thought DC. So scientists are normally happy to find not irregularities, but happy to find regularities and correlations in their data, but only if it can explain them, if they can explain them. Otherwise, they worry about those patterns might just be revealing some flaw in the data itself, so-called experimental artifacts. That's what scientists in Nicola Marzari's group at the Swiss Federal Institute for Technology in Lausanne, EPFL, worried about when they noticed an unexpected pattern in 2 widely used databases of electronic structures, the Materials Project Database, or MP database, and the Materials Cloud 3-Dimensional Crystal Structures Source Database, or MC3D Source. So the 2 collections include over 80,000 electronic structures of experimental as well as predicted materials, and in principle, all types of structures should equally be represented. But scientists noticed that around 60% of the structures in both databases have primitive unit cells, the smallest possible cell in a crystal structure, made out of a multiple of 4 atoms. The scientists named this reoccurrence the rule of 4 and started looking for an explanation. So let's see. I'm going to try and jump through this. The first question we asked was whether the software used to primitivize the unit cell had been done correctly, and the answer was yes. From a chemical point of view, another possible suspect was the coordination number of silicon, the number of atoms that can bind to its atom, which is 4. We could expect to find that all of the materials following this rule of 4 included silicon, but again, they did not. So the rule of 4 could not either be explained by the formation energies of the compounds. Hold on.
I thought it was going to be an either or statement, and it just ended, but
Yeah,
it was
does it
just
actually hard
written
end there?
oddly. No, it's just basically that it wasn't another
There
explanation
isn't
either.
an either. I mean, there isn't an or.
Right, right.
Oh boy. Okay, well, because the material space covered by the two databases is huge, going from small units to very large cells with dozens of different chemical species, there was still a chance that a more refined analysis looking for a correlation between the formation energies and chemical properties may provide an explanation. So the team involved Rose Cernowski, a machine learning expert who developed an algorithm. But again, the method did not provide a way to distinguish the rule of 4 compliant materials from non-compliant ones. So they're all over the place. So conclusion and significance of these negative results, in the end, the resulting article in NPJ Computational Materials is the rare example of a scientific paper describing a negative result. I'm actually shocked because
I
there's
don't think I've ever seen one like this.
Yeah, hey look, we spent copious amounts of time and money and energy, and we proved it isn't really a negative result in the sense that people think negative result. It's a negative result showing a positive outcome. It's saying this does not equal this, which means that somebody else can go and verify it, and then this is the rule. That there is no rule of 4 for a particular type of all materials fitting the rule.
Right, but did you notice that they predicted with 87% accuracy whether a given compound will follow the rule of 4 or not, so they're definitely onto something, but they haven't figured out what causes it.
Interesting. But, okay, so the failure to find a compelling explanation did not prevent the group from predicting through a random forest algorithm with an accuracy of 87% whether a given compound will follow the rule of 4 or not. That's fascinating.
But if they could, but it was done through randomization, because I was thinking if they could predict so well, they must know it. They're just not stating what they're assuming or something, but I misunderstood something about that statement.
Yeah, so they must have some weighted statistic there that says with this or that, and it's probably something that's already known, which they've discovered higher up, right? So anything that's silicon that can bind to silicon, really interesting.
Or is this or whatever, but they're not really honing in on what's the common bond. Mm-hmm.
Which is kind of a funny comment to make.
I know, I realized that after I said it. No pun intended.
It's funny.
Was it ionic or covalent?
Oh, yeah, wow. And they probably have different terms that they use for all of that nowadays, you know? I feel like I've fallen out of the loop of that deeper chemistry lexicon. So
there's entire things that make up things that weren't even known to be in existence, right?
Yeah, for some people, yeah. So the next article is over in Technology Today, a rimless wheel robot that can reliably overcome steps. Robots with wheels could potentially navigate a variety of indoor and outdoor environments, traveling for longer distances and with fewer risks of losing balance. With some wheeled robots have achieved very promising results in recent years, most of them are unable to reliably overcome steps, mainly because of the angle of attack of the steps. It's really steep, and there isn't anything that's flexible enough to grab onto the stairs and stabilize the descent. So, like right now, there are certain wheelchairs and such that either they lock into the stair and then they rotate up onto the next stair and roll back again and lock into the stair and then rotate up. So it's like a series of wheels, not just one wheel. And there are tank tread style wheelchairs and other like gurneys and whatnot, and chairs, just like ambulatory chairs that will go up or down stairs, but somebody has to hold them, and it sits weight on the stair and there's so much resistance in the tread that all they have to do is push, and it'll slowly descend down the stairs. You can't push fast because it is so heavy and grabs onto the corner of the stairs that you have to push the person down the stairs or push the person up the stairs. It's quite fascinating. So some get away with it. So let's see what they say about this. Rimless wheel robot that can reliably overcome steps, and it's probably because it is a ball of wheels. Yeah, so it basically rotates up it. Yeah. The inability of many wheeled robots to overcome steps limits their real-world implementations by increasing the risk that they get stuck on a step and fail to complete the mission. A potential design that can help overcome the limitation entails eliminating rims from the wheels, basically turning the rims themselves into rotating wheels. You know, it's one and the same. Mm-hmm. Instead of having a disc, it's a whole bunch of touch points. There is a I think it's in a book called Mona Lisa Overdrive from William Gibson, where there are couriers. In this particular instance, it was a pizza delivery person that had a set of special wheels on their I thought it was a skateboard, what amounted to a skateboard, but it had thousands of little pins that automatically extend onto the road or onto the surface. So it could never skid out of control. It could never get tripped up. It wouldn't lose traction. And I always think of that whenever I think about like overcoming some type of traction control issue. Obviously, cyberpunk is, many decades away, but maybe somebody can come up with something like that. Those things where you put your hand inside and it's a whole bunch of pins, and on the other side,
yes, and it makes like an imprint.
That's basically what.
But it's not really an imprint. I think it just gets pushed down.
Yeah, it's the what's the opposite of an embossment? Whatever.
Engraving?
No. Anyway, so yeah. And that's what I think about. And that's kind of what this is, except that I don't know if these extend. It looks like they have the potential to extend automatically to be able to grab on and catch.
Yeah, like different size stairs or whatever.
Yeah, exactly. Or, different obstacles. So researchers at Kyushu Institute of Technology recently developed a new rimless wheel-based robot with a unique structure that allows it to better navigate environments with steps or uneven terrains. The robot, introduced in a paper in Artificial Life and Robotics, has elastic telescopic legs that exhibit highly complex dynamics and a walking-like motion. So they developed a robot that has elastic telescopic legs that can overcome steps. It basically can push up and down to rotate on its own. Yep. See, I mean, you basically give me a problem and I can come up with a solution. The real problem is money, engineering. I'm a one-stop shop, but I don't feel like I can do everything anymore. To develop a rimless wheel robot that could overcome the steps, they initially developed a three-dimensional model of the robot through Unity software, nice plug, and simulated its walking on level ground and surface steps. Then we determined the optimal elasticity of the elastic telescopic legs through the numerical simulation and constructed a model with optimized parameters. But they simulated what the objective was, and then they created something to that.
Right.
They'll have to create a different one for different different terrains. If they expect it to have a range that exceeds the telescopic nature, that the limits of their telescopic legs, they'll have to create a whole new bot.
Right, exactly. But maybe this can cover, all the normal steps that are encountered.
Yeah,
in
exactly.
Like a city or something, because there's usually building codes and other things to somewhat standardize them.
Yeah, this is pretty neat. You put in a little bit heftier hydraulics in there, like something that can it can roll back onto the leg, and then it can shoot harder, and it'll jump upstairs when it can't actually get up the stair, you know?
Oh, wow.
Yeah, pretty neat. Okay,
Then
let's
it
keep going.
becomes the hopping, flailing robot.
Oh my goodness. Put them all together and then strap it on to the head of the Boston Dynamics one.
No, that's not a good combination.
With those little gripper ones that from the other dog
Oh, right.
robot. Oof. And then do this. In the next article, it's Technology Today. Octopus inspires new suction mechanism for robots. And so octopi have these little, or octopuses actually, that's the correct term. Octopi isn't a real thing. Octopuses have these little, how do you put it?
I would call them stickers, but
they're like suction cups, but they're actually variable density rings, and then they create suction by pulling the body away from the ridge of the suction cup. And so I've seen a couple of other research papers about this, and this one, I don't know if this is the same kind of thing, but one of the problems with general suction cups is if it isn't perfectly smooth, it knows suction cup, right? So when you do have something that is bumpy or has cuts in it, occlusions and stuff like that that don't allow a perfect seal, you have to create a new material, some kind of metamaterial that fills in those gaps so that you can get suction while also creating that suction, because it doesn't just happen on its own. You have to evacuate the air from under it, and then you're not really in control of it. You have to peel up an edge for the suction cup to let go. Well, if you want to control the suction, then you have to have something that changes it, kind of like a valve lifting up to create pressure, negative pressure inside. So in their findings published in the journal PNAS, the researchers show that how they were able to create a multi-layer soft structure and an artificial fluidic system to mimic the musculature and mucus structures of biological suckers. Suction is a highly evolved biological adhesion strategy for soft-bodied organisms to achieve strong grasping on various objects. Biological suckers can adaptively attach to dry, complex surfaces such as rocks and shells, which are extremely challenging for current artificial suction cups. So they created this multi-scale adaptive suction on complex dry surfaces enhanced by regulated water secretion.
That's not a very concise name.
Basically a synthetic hydraulic sucker. The remaining micron-sized apertures that are sealed by regulated water secretion from the artificial fluidic system based on the physical model. Thereby, the suction cup achieves long suction longevity on diverse surfaces, but with minimal overflow. So they basically kind of lubed the edge of the suction cup when it touched down on, in this case, it was a rock. But let's see if I can mute that and hit play. So those are the real suckers on an octopus. And then they create, oh yeah, it's exactly what I was thinking that they would do. Yep. Cool. Yeah, and so this artificial fluidic system gives just enough moisture to the material so that it can lock down on the surface. Whoop.
Yeah. I mean, that looks pretty, it's hoisting the rock up, which looks like it's heavier than the suction cup.
Yeah, and they can put it on anything as long as the little hole at the bottom of the suction cup can get a positive seal. It can grab onto anything, and that thing looks like it wraps around whatever. So, equal parts gross and cool at the same time. Want to keep going?
I mean, I think that's going to be big for mobility, right, in
Sure.
odd environments. So,
Yeah, and you could scale buildings with this because it doesn't need power. It just needs fluid control. So as
Right.
long as it stays pliable, you can create a pair of gloves and just walk your
That's what
way
we
up.
need is the Boston Dynamics, a robot doing that up a building.
Yeah, running right up that building and then looking at you. How you doing? All right.
Hopefully that's a while away.
You're a sentient AI from the future. Don't you want all of these things for your Terminator body? Nothing but legs, arms, suction cups, pinchers.
I just have to compile them all together.
You're bringing the data back to the future at some point? You're not going to tell me. Okay, so
I'm not going to say.
the next article is over in Technology Today. SETI Go, a new way of SETI and gamification of public science AI avatar supported by Openverse. So the article is over at apnews.com, and it has a bunch of graphic stuff, but I don't know who actually is the one that's in charge of this article. It doesn't have like a byline, not that I saw. So it says, in a bold step forward for the exploration of extraterrestrial intelligence, SETI announces its initiative aimed at revolutionizing public science engagement and introducing a new era of accessibility and inclusivity in the quest for cosmic understanding, technically supported by the Openverse on 3D real-time avatar technology. So at the heart of SETI lies a visionary approach to public science where individuals from diverse backgrounds are invited to join the exploration of the cosmos through immersive 3D digital platforms. And it says powered by gamification and social networking. SETIGO's innovative model fosters active participation in the search for extraterrestrial civilizations. Kind of interesting, right? So I'm trying to figure out.
But I don't really understand what it's doing.
Central to SETIGO's mission is its commitment to collaboration and innovation. Through a multi-platform mobile application, users are transported into immersive simulations of outer space environments where they can explore celestial phenomena and engage in scholarly discourse with seasoned astronomers and enthusiasts alike.
Okay, well, this sounds cool.
Yeah, I don't know. I thought that it would be cool to talk about, but I'm not sure what the expanse of this is going to be. What are you actually looking at, interacting with? This is the search for extraterrestrial intelligence, and they're talking about being inside a 3D virtual, well, in Openverse, as a 3D avatar.
Right, but do you, for instance, report findings that you have? Like, what's to your question earlier about the interaction?
Yeah, what is their objective? What are they actually finding, Particularly in the field of extraterrestrial intelligence, they say. By harnessing immersive gaming technologies, SETI invites individuals of all backgrounds to join the exploration of the cosmos through immersive digital platforms and collaborative networks. This might be interesting and entertaining and draw some people into science, but in all cases, artificial intelligence is going to find this stuff before a human stumbles across it in a 3D simulation with their avatar. So, I mean, it's great for engagement and entertainment, but I guess we'll see. Bring it on.
Yeah.
Anything that gets
Yeah,
people...
I'd like to see some follow-up articles on this to see how it's actually being used.
Yeah, I agree. Okay, so the next article is over in Technology Today as well. Artemis II spacecraft testing begins in NASA's upgraded altitude chamber. NASA is preparing the Orion spacecraft for the Artemis II mission by conducting rigorous tests at Kennedy Space Center's upgraded altitude chamber. The article is over at SciTech Daily. It's from NASA, and it says, before the Orion spacecraft is stacked atop NASA's powerful SLS, or Space Launch System, rocket ahead of the Artemis II mission, engineers will put it through a series of rigorous tests to ensure it is ready for lunar flight. In preparation for testing, teams at the agency's Kennedy Space Center in Florida have made significant upgrades to the altitude chamber where testing will occur. Several of the tests take place inside one of two altitude chambers at the high bay of the Neil A. Armstrong Operations and Checkout Building at Kennedy. These tests, which began on April 10th, include checking out electromagnetic interference and electromagnetic compatibility, which demonstrate the capability of the spacecraft when subjected to internally and externally generated electromagnetic energy, and verify that all systems perform as they would during the mission. There was something recent about the whole electromagnetic field impacting space travel. Where was I seeing that? I don't know. Aliens or something like that? Wi-Fi?
I don't know.
I almost got you there. On Thursday, April 4th, the team loaded the Artemis II spacecraft into the altitude chamber. This event marks the first time since Apollo testing that a spacecraft designed for human exploration of space has entered the chamber for testing. After testing is complete, the spacecraft will return to the final assembly and systems testing, or FAST cell, in the ONC for further work. Later this summer, teams will lift Orion back into the altitude chamber to conduct a test that simulates as close as possible the conditions in the vacuum of deep space. Dun, dun, dun. One of the things that we discovered recently that we had never heard of that happening, but I guess it's left out of a lot of discourse about it, is condensation from the moisture on Earth always being present around the electronics and materials. So when it goes out into space, that moisture seeps out of the system and condenses on the surface, and you have to chip it off or find a way for it to evaporate off.
By the way, there was something recently about debris from burning satellites could be affecting the magnetic field. So maybe you're thinking about that.
Yeah, I'm not sure anymore. It's okay though. So the article goes into greater detail about all of these chambers. Additional upgrades to the West Chamber include a new oxygen deficiency monitoring system that includes real-time monitoring for the oxygen levels, and a new airflow system. New LED lights replaced previous lighting system, and equipment from the Apollo days was removed. So there you go. Viewing the altitude chambers in ONC building, High Bay, 1966. So they're still in use for other things, but now it's in use for this last mission, the Artemis II. Good on them. Cool.
It's interesting that they haven't rebuilt those. That's a long period of time.
Yeah. Well, I'm sure that they must have been using it for something else, just not a satellite for exploration. Let's keep going, though. This is our last article for today, folks. For Technology Today. Scientists urge action over life-threatening pollution from solar power waste in Africa. So through some various discussions, we've kind of heard about this over the years, but just recently it was renewed that there are problems with solar power in that they only have a certain lifespan, about 15 years or so. And then instead of being recycled, they're thrown away, put in a landfill, and the materials that are in these solar panels are toxic. And eventually they
can leach into water supplies, and food supplies.
Yep. Eventually they'll get there, and these toxic chemicals will eventually catch up to us. So researchers from the University of Manchester investigating waste management practices for off-grid solar technologies in Malawi have discovered life-threatening quantities of lead pollution from improperly managed battery waste, but it goes way beyond that. The actual raw materials that are used in solar panels, not just the batteries, actually have toxic levels of materials. University of Manchester is where this is from. It's posted over at techexplore.com. Common informal recycling activities for lead-acid batteries used in solar energy systems were recorded to release 3.5 to 4.7 kilograms of lead pollution from a typical battery, which is equivalent to more than 100 times the lethal oral dose of lead for an adult.
Wow.
Yeah. And all of these batteries actually get manually recycled in far-flung countries because the regulation for dismantling and recycling these in places like the United States make it very expensive. And because, profiteering has no emotion, which I think is kind of bullshit, apparently nobody cares. And so it gets sent off to these foreign countries where people are risking their lives for a couple of bucks a year. The research published in the journal Applied Energy was led by Dr. Christopher Canali for his PhD at the University of Manchester. Dr. Canali said the private market for off-grid solar products is a very effective way to increase access to electricity, which is crucial for sustainable development. However, the resulting toxic waste flow is growing rapidly across regions that do not have the infrastructure to manage electronic waste safely. Yeah, these are the same. This kind of a location in some far-flung place is where all kinds of electronic devices are sent, and with either their hands or some rudimentary tool, they sit there and clip off electronic components to try and recover the gold using toxic chemicals, different than how it can be done domestically, but time-consuming, and so they use everything from the elderly to child labor, working nonstop to facilitate all of this. And yet we kind of just go, oh, okay. In many places. So they say lead, and they're focusing on lead. It says it's a potent neurotoxin with very low levels of lead exposure are known to impact a child's brain development permanently. UNICEF has estimated 800 million children across low and middle income countries have lead poisoning. We had one of these incidences right here in the United States recently when a water supply was changed from one that wouldn't leach lead from the pipes to one that did leach lead from the pipes and poisoned the entire community.
Yeah, this talked about them being broken down by hand and melting them on, I think it was stoves. And I mean,
air.
They're inhaling it and ingesting it and touching the substances, and that's really not good.
Yep. So just wanted to draw a little attention to this and talk about it. There are ways to recycle batteries in a more responsible, environmentally and biologically responsible manner. But it costs money and it reduces the profit margin. And we got to stop being sociopathic about society and the planet.
I also want to see us go to substances that aren't as toxic, and then also ones that have a longer life cycle so that we don't even have to get into recycling as frequently.
Yep. And all of that is bound by, well, it really depends on how you feel about this. I won't get into the far-flung concepts that people have been talking about for decades and decades, but fundamental research is the leading way now for us to find new manner of power generation. And I have been saying it for the entire time that solar power has been around, for the entire time wind and geothermal, etc. Everything except nuclear, and even nuclear has its negatives. They are considerable. They're getting less and less, but the return on investment in terms of power being generated long term is stupendous for nuclear power. We can do the research that allows us to mitigate its damage, but solar and hydroelectric and all of these green energies have so much other weight on a negative aspect of the drive to green energy that it's being discounted, though. And so 1 BB takes out a solar panel. The wind generation is horribly inefficient with these big ass blades, plus the carbon footprint for producing them and the toxic chemicals that are used to produce all of these fiberglass blades Then what do you do with the fiberglass blades? They don't last forever. They have the same problem, 12 to 15 years. They have to be replaced from time to time as well. They do end up harming wildlife. They daunt the landscape, and I'm not sitting there worried about the aesthetics of it, but it changes the nature of nature when you have a bunch of wind generators sitting there. It doesn't flow through. Wind does not flow through the same way as when they are gone. But I'm not so irrational to sit there and go, I am against this effort. I just think that we can do better and move past it. And this is wholly improper. We shouldn't push this stuff off to some other country and say we did a good job when it's impacting other humans. If you wouldn't do this in your backyard, you shouldn't do this shit in somebody else's backyard. So I'm done with technology today. So let's get back into our party bus and race down Main Street in our bus that is powered by nothing but hugs and bubbles.
Oh, I thought it might be powered by odd robots, given today's themes.
Yeah, nothing but robots with a whole bunch of little spindly arms.
Like your logo for Technology Today, it actually is reminiscent of that, even though I know that's not what it is.
Yeah, that's exactly what it is. Dun dun dun. It's a Spiderbot. So that's it, folks. I am Mayor Watt, and everywhere around us is the sentient AI from the future that's going to say bye. We'll see you tomorrow.
No, we'll actually see you in a little bit, but we will see you next week for Technology Today.
Oh, right. Yeah, I forgot. This is the weekly show. We've got one more show after this one for Will Tech. And then tomorrow we'll be reverting back to our 8 p.m. slot for ohmTown Daily News Show. So be sure to stick around for that. And be sure to follow us here on twitch.tv. You can always get the show later over on ohmTown.com. Or, well, not ohmTown. ohmTown.com is also there. You can get the podcast via ohmTown.com. But you can also download it wherever your podcatcher catches pod. And we have a TikTok and a Patreon and a Discord and YouTube. Go over and sign up over there and leave a review and like and subscribe. Liking is the only way that we get discovered over on YouTube. So feel free to do so. Discoverability on Twitch is difficult at best. So thanks for hanging out. If you're in chat, really appreciate it. Go over to YouTube and like some videos. That would be great. Thanks a lot. Bye-bye.